Being Docker should one of the same host system. Docker has similar concepts. So what is the underlying difference that we should?
Actually, there is a very a good diagram about that. We don't have it here, but it's a big discussion. But basically, here you are sharing your host's kernel, and in the host operating system, you are sharing the host kernel basically, and in what traditional virtual machine like VirtualBox or VMware, that's running its own kernel, it's running its own operating system. That's the crux of it, but it's there's a very good diagram on that. You can take it on maybe the Docker's official website.
Plus, it's also very lightweight. So
yeah, it's a lightweight standalone and can be easily used for microservices and distributed applications.
It scales very, very
Correct.
From application package point of view, does it also like become the application platform independent kind of a thing?
Yes.
Right. Yeah.
So what is the best practice over here? Whether to bundle the application within the image or we should keep the application code outside the image?
So you're talking about whether to like copy or burn it or whether to mount it. It actually depends. So for a use case where you don't want to build an image every time you change some piece of code, then you can just mount it. But if you want the whole image to be built again, then you have to burn it. Then you can burn it if the image build time is not that high.
But next time if you build a system, it will get the data from cache, right?
So like I talked about. So we have many instructions for that. So if any of the instruction set is changed, like if you have a copy command, you are copying your code into your image, then after that command, all the images, even that is in the cache or not, it will execute. So it's preferable to mount and keep the things below.
Or maybe keep the copy command at the last.
At the end, yeah.
Correct.
That is the best practice.
Whatever the dynamic changes, that should be in the lower part of the code.
Yes.
Yeah.
So, what are the security challenges we face into this document? So, risk of running containers with privileged access. So, by default, if you run an image as a container, it runs as a root. So, if you get the root access inside a container, it is very easy to get root access on the host. And by default, the namespace of process running inside the container and that on host are same. So it is, if you get the root access on host, so your code and your application is definitely in a very dangerous state. Interconnector container attacks. So while talking about multiple containers on same host, if one container is originating some attack, like any kind of malicious code or any kind of attack, it is highly probability that the resources that has been shared by the other containers as well, it will not work properly. Then I'll show you a demo on this thing. So denial of service attack. So in denial of service attack, if in this one container sees all the resources, the control of all the resources and the other images on the host does not work properly. And poisonous images, as Mr. Trump has told you, that the by default registry has some official images, some public repositories, some private repositories. So while using an image-based image like Ubuntu, Alpine, or any kind of image, just make sure that you trust the developer or trust the person from whom you are pulling the image. So it is recommended to use the official images rather than using public repositories. But yeah, if you trust that person or that repo, you can definitely use that. So the problem behind this is that if you don't trust and put any public repository image, it may contain some malicious code, and you never know when that malicious code runs on your host and just goes, it makes your data unavailable.
Sorry, you mentioned some full form of this. What is it called?
Denial of service.
So I have one query, like
since we are running multiple Docker containers on a single machine. So what is a good choice? If you run a multiple microservice on a single Docker or run a individual microservice on an individual Docker?
So having a container for each service is beneficial in terms of microservices architecture, wherein you want to deploy just one application, just one service, and make sure others do not have to be deployed. So if that's the case, then I would say go for a container for each service.
So let's suppose I have a use case. Let's suppose we have a developer. So we have a development team, right? So every development team have their own systems, right? So we want to conclude a single application architecture to each developer, right? So how we can proceed for that? We give the complete Docker images to those guys, or create a single image and push it.
So I think if talking about the DevOps culture, if the devs are comfortable with maintaining the Docker image as well, it's pretty straightforward, like just building an image or building an image out of your application. If they are the owners, then it makes sense to just have each team have their own Docker image and maintain it, and then it becomes easy to deploy them individually. Anything just in the
Possible if we can point to this point that it is possible if we can orchestrate all this through build server or through deployment server itself.
So if you're talking about orchestrating different containers, there are various services. I know there's Kubernetes, there's Docker Swarm as well, wherein you can orchestrate the containers, multiple containers. Any more questions around this? Okay.
Let's show how risk of getting access on host can harm our application.
So it's a bit ironic for a Docker demo we are using virtual machines. But this was done because we were trying out stuff that could bring down the host, so we did not want to have a official max down. That will be bad for the project.
So in this window, I am running as root. It is my host.
Is it readable at the end? Can you increase the font?
So in this window, I'm audible, right? So in this window, I'm running my application as a root, and here I'm running myself as my user. So let me
So you need to be a root user in order to have
So to run a container, you can run it as your user.
So I am running my container as my own user. So if I say I don't have an image right here, I will say Docker full. I'll find the 3.5 tab. It's very small image and hardly takes 2 seconds to install. So I have my Alpine ready with 3.5 tab. Then I'll say Docker run. So by default, Docker run runs the container as root. So if I say Docker run and I'm into an interactive session with terminal, mounting, I'm mounting my host whole file system to an app folder, giving the entry point as sh and with my image 3.5. Is it clear now?
Yes. So it's actually checking the assets latest one. Asset will be last one.
I'm inside. I have run my image through my user, you can see there, and I am root inside my Docker. So if I see, I have mounted my file system into an app. So see app. If I go to M folder,
Couldn't see the output of the last one because your government application is very good on the top.
so I just so right now I am on root. I have my app mounted here. So initially I wrote command docker with
Volume for
volume on for root to app. So if I go to app and then go to M folder, I can see this particular file set. And if I check my root window, I'm inside my tent. I can check everything here as well. We have a GeekNight folder there as well. So if I say ls, by default, this GeekNight file has a root access, right? Or I can create another.
What are we trying to do?
So I'm telling you how root access can harm your system. Yeah. So,
A normal user in Docker will remove your file, which is
GeekNight is a user and it is trying to get into a root user now.
a root user of a host system.
So when you ran the container, you ran it as a normal user, but by default, whenever you run a container, it runs as root inside the container.
so I have created a zonao.txt and I can see here that it has a root access. So if I see in my container, I got my zonao.txt here and
It's
right now
not in the
inside,
container, I guess.
it's inside my container.
This one is the
How did you come to know that it is not in the container?
that virtual object is free running in time.
The prompt.
The prompts are GeekNight. So
I got my zonao.txt here. If I from my container, I am removing my zonao.txt.
RS.
So it's no longer here, and yes, it's no longer there as well. This is my host. This is my container, right? But if I say I'm still my user, I've exited that container. Now I'm running the same command with my user.
So this is a way to run a container as your user. So if you pass in these arguments, id-u is a command to give your which outputs your user ID, numeric user ID, and this is the group ID. So if you pass in these parameters, the container will be run as your user, whichever your user is on this host.
So if I now check, I'm from an unknown user, I'm not logged in as root. So let's see, I have my app mounted here. I will go to app, then go to then. Okay. Now I'll switch back to my host and we'll create a new library. Let's name the file. Touch opener. I can see my file with root access there. Now if I switch to my opener file here with root access, but since I don't have privilege of root, I will not be able to delete this file. It's asking me, I say yes, and it is saying that operation is not permitted. So by this we have explicitly said that don't run it as the root, run it as some user for which you can control the permissions, and this is how we can actually just prevent a single security thing we can keep in mind and work around this.
So this is one of the examples we saw, that how to prevent someone from running containers as root on your host. One thing I would like to point out here is every container you run or all the images, they reside on the host. So even if the client is running on any other ABC machine, and if on the client I run docker pull Ubuntu, the actual image will be pulled and kept on the Docker host where Docker daemon is running. That host can be XYZ host anywhere. So the risk here is of getting our host which is hosting the Docker daemon compromised. Any questions on this?
The last point that you said that I'm working on a local machine and I'm trying to, and I have a server or that server, that server, and then if I try to run a Docker command, so I'll have to run over there with that server. I thought that would not happen.
No, so you can have your Docker client, which is on your local machine, point to the Docker host, which is running on some other machine. Obviously, if the connection is allowed, if they are on the same network, or if you are explicitly allow connection on your host. And we will get back, we'll talk more about this in the coming demo. Okay, so this was a demo about what are some of the security challenges while setting up Docker. Now we'll talk about how we can avoid them. So the default Docker authorization model is all or nothing, which basically means that if as a user, if I have access to Docker host or the Docker daemon, I can basically do anything. So like you saw, I can simply say Docker run a container name and it will run as host. There's nothing or no one stopping me from not giving some parameters which can make it more secure. So this is the default authorization model. Now to fix this, there are already a lot of things that Docker provides. It's just that we should know how to set it up properly. This is particularly helpful when you are running multi-tenant Docker host. You are allowing multiple clients to run their applications. So this will come in helpful to set up permissions and authorize them in such a way that a few set of users are allowed to do some actions and some are not allowed. So for authentication, the simplest way we could think of was to have a mutual TLS authentication. We'll talk more about this. And then for authorization, once I know who my client is by this step, I can then put in some authorizations. I can put in some rules, I can put in some policies to make sure that they are running the command that I, as a owner of Docker host, want them to. And then there comes a part about, like I talk about, enforcing that some things are done, like passing in the -u parameter to make sure that you are not able to run as root, and making sure you are not able to maybe mount a volume that you don't have permissions to. So this is a basic diagram of how authentication takes place. We will be demoing it in a bit, but this is just to give you an overview. So we have the daemon running where we generate the CA, we have the trusted CA and we generate the server certificates. We have two set of clients. So one is where we can trust because they are providing me the valid certificate which is signed by the CA I trust. Other ones are which they don't have any certificate or they have an invalid cert and they are trying to access. So in first case, since the request is coming from valid certificates, the daemon will authenticate and give back the response. And in the other case, since there are no certificates, daemon will the Docker daemon should just deny that. So this is simple mutual TLS. And why mutual? Because the clients are also validating the certificates that the server is providing. This is the authorization flow in Docker. So Docker allows easy integration of plugins, and with these plugins you can do a bunch of things, and authorization is one of them. How it works is when you run the daemon, you specify that I want to run it with this particular authorization plugin, and then this is the added flow. There is an so suppose I was a user with no permission to run a container, but just list containers. So if that request goes through, I will check with the OTC that whether this user in this group has the policy to run the container, and I'll get no as an answer, and I'll deny the request with the error message. And it's up to the daemon actually to pass that error message to the client or not. Any questions on this flow? We'll be demoing this, so maybe it will become more clear.
So where this ODC plugin is from? It's daemon side?
It's we were able to find an open source authorization plugin written in Go, but it is so you can create your own as well. You can write an authorization plugin, or the one we found is actually extensible. You can extend it to include more fine-grained control if you want.
It's not part of the Docker daemon.
It is not part of the Docker daemon.
Any other questions?
Okay, so these are some of the policies that you can enforce. Just I'll just walk through them. Like she mentioned, if you run a container with -u flag, it will make sure you are not able to run as root. There are various capabilities, and these are like the Linux capabilities, which allow you to do some special or do something to give you some privileges while you are logged in. So you can drop these as well. Docker allows you to do that by passing in these parameters. Then there are control groups and namespaces, which are basically the technologies that Docker leverages. These are again age-old technologies from Linux, which Docker uses to containerize and run applications. So if you read up about this, you will figure out some ways to how to best utilize. So for example, control groups allow you to set limits on how much memory and how much storage a particular container could access. So that can allow that can prevent the denial of service attacks. If I am limiting my memory consumption of a container, it will make sure that it is not able to disrupt the other container. They get their due memory. Then there are like again poisoned images. You should avoid any images from developers or maintainers you don't trust because they can be malicious. You can never be sure. There are official images which you can trust. I'll get back to you. And there are of course images which are extremely famous and you know that they won't do any harm. Yes.
how would you expect the set UID? Can you explain?
Again, these are some of the capabilities which allow you. So set UID capability allows you to change your user. Again, I have not played around with this a lot, but so there's a net bind service again which allows you certain privileged network operations. But with Docker, you again when you do Docker run, you have the capability of you have the ability to drop this capability or any capability that you have.
So how namespaces can be exploited?
So namespaces, again, these are helpful, again, not personal experience, but these are helpful in limiting your container scope so that it is not able to interfere with other processes on other. Some of the namespaces that are used by Docker are the process namespace, which is the process PID in Linux.
By default, the namespaces of the processes and which you run inside the container are same as that of host. So if you just play around these things to control that nothing goes bad around the host and no other container can interfere in that.
There was a question, yes.
So, is there any strategy or architectural pattern you would like to share to address data in motion risk?
To address
To address the data in motion risk.
data in motion. Okay, can you explain data in motion? I didn't get that part.
The data which is not secure when we are working with the document data.
Oh, you're talking about sensitive data, is it? Let's talk this maybe. It's not in the scope of this talk. We won't be covering it here, but we can definitely talk about this maybe after the talk.
Okay, so if I understood correctly, using capability drop, we can remove those capabilities of a user which can actually compromise the security.
So
Correct.
by default, Docker provides certain fixed number of capabilities to use. So set UID, set GID, and then netbind service are one of them. So as we said that set UID, you can change the users. So if to control that you don't change to like you don't escalate to root access, you don't give permissions to other users. So we can drop this capability and work around.
Okay. Now, let me show you some demo of authentication and authorization come into play. Is it visible at the end? So what I have done is this is a directory where I have created all the certificates I was talking about. There is a CA cert, there is cert for server, there is cert for client. For simplicity, I am running both the host and the client on the same, the Docker daemon and the Docker client on the same host. But what I'm doing is when I run the Docker container, by default on Linux it listens on the Unix socket. But as you can see, if you provide your host IP, which in my case is a local host, and a port to listen on, it will start listening. So this Docker daemon will start listening on this particular host port over for HTTP connections. So if you have a client running on some other host, they can also talk to this daemon. So this is a plain Docker host run. Oh, sorry.
Just normal logs.
Yeah, but I hope I drag this up. Maybe I should just. better. Alright. So this is running and listening on this particular port for connections, and this is plain Docker without any authentication or authorization. Now over here, if I do a simple Docker PS, it will obviously allow me to list all the running containers, or it will allow me to list all the images that are there on the host. So this is a basic normal Docker flow. Now let me try and run it using the certificates. So this is where we put in the mutual TLS. So how you do it is, can you all see the command? No. Or you can? Oh, no, you can. So what I've done is, this is a flag which says the TLS verification has to be there, and this is the CA cert I trust, and these are the certificate that you have to serve to the client. And again, I'm listening on the same host on the same port. Now if I run with this, and now if I try to run a Docker command, it fails because it wants me to, as a client, it wants me to send in the certificates, the client certificates, so that the server can verify that they are signed from the same from a valid CA and allow the request. How you do that is something like this. In the client, there are very similar arguments. You can say I want to verify, and this is the CA cert that I trust, and this is my cert that I want to present. Now, since these in Docker docs, there is a very nice page where you can generate the certs using OpenSSL. So I went through that and I generated both the certs by signing from the same CA. So it should trust this certificate. So now, as you can see, this worked. So it is listing the images, and it is basically allowing me to do anything that I want to do. If I can. Oh, because no, sorry. Yes, I can pretty much run any command because currently there is no authorization. Now, talking about this particular container, so this is the authorization container the authorization plugin I was talking about. I have containerized it, which is again provided by the authorization plugin, and I am running it. And there is also a binary where you can specify in the Docker run command that I want to run now with this authorization plugin in place. So now to do that, you can do something like this. So I'm saying the exact same argument still here, and I've added that I want an authorization plugin to be in place. So let's try to do this and see what happens. So again, it is listening at the same host and same port. Now let me try to, so of course this should fail because of the TLS. Oh, sorry. So this fails because of authentication failure. Now if I try to send in valid certificates, it works. That was a wrong command. So I should have done images. I'll tell you the reason why. Oh, this also works. Damn. Okay.
I guess your earlier command is already running.
I guess what I've done is, so now it's trying to talk about the policy file. So it is talking to the authorization plugin, but currently in my policy file, which I will just show you shortly, if this password is correct. No. Yeah. So this is the policy file, and here you can see there is a name which is just the policy name. Users, I have conveniently called my user the client to avoid any confusion, and the actions. So currently empty action array means that I allow all the commands from this particular user. Now let me try to put in let me try to put in image list. So this basically what I've done is I've changed the policy, I've changed the action to say that from this particular user just allow an image list, which is the name of the action you do, which is performed when you do Docker images. Okay, and the good thing is it loads by default. You don't have to rerun your Docker daemon or you don't have to rerun your authorization plugin. So now if I do images, it should work. If I try to list containers, so this is the denial message that I'm getting from the authorization plugin. It says this authorization is denied by plugin. This is the action container list and it is denied for user client by such and such policy. Now, just to prove this works, I'm going to add this action as well. Let's save this.
So these actions are already defined in ODC plugin, right?
Yes, so these are the actions that that are there in the REST API specification for Docker. And authorization plugin basically uses the same. Now, if I now it is allowing me to list the container system.
Okay. Firstly, I'm trying to understand how authorization is done with certificate. First,
Sure.
the server lists what certificate it expects the client to give.
Yes.
And how are those certificates actually got by the client? Or how are those certificates generated?
So for the purpose of this demo, I just generated using OpenSSL. You must, if you haven't heard of it, it's just a simple way to generate certificates.
So if anyone can generate those certificates, then there is no security.
So you have to have them signed by a valid certificate authority. So like I mentioned in this case, for simplicity, I signed them with the same CA. So the server trusts the certificate which the client is providing. This is the case of like simple one-way TLS authenticator auth which is there on any website. So if you open, let's say facebook.com, your browser trusts the certificate that it provides and it allows you to open that. But you must have seen some shady websites providing you certificates which are not trusted by the browsers or the CAs.
I've never visited any certificate.
There goes one of my secrets.
What the self-signed certificates work over here?
Yes, I am using the self-signed
For
certificate.
internet-based, if it is an internet-based application, you can use OpenSC. If it is not open to the internet, so if it is open to the internet, you can go and buy with any CA certificate, right?
But otherwise also the Docker, generally the Docker client and the daemon run on the same host. So the interaction is on the same machine.
So that is not always the case. So it is true in this case, but you can always have a Docker host running, Docker daemon running on some other host and Docker client on some other host talking via REST API. Yes.
So can you counter India's maintenance sector because it's flowing through
Yes. Kind of aware of that, but that is again a very big question that will require a lot of discussion. So let's take it offline.
I mean, yeah, patch is there, right? So Docker has a plenty patch. Spectre is hard, but Meltdown you can tackle.
So that's an important point you have there. We have to make sure as developers, as the owners of our images, we have to make sure that we are using the latest images, the base images that we are using. So if we are using Ubuntu and if we hear of such exploits, we should make sure that we update the image, we pull in the latest image with the security patch and make sure that our application is secure.
Is there a way to write only those commands which are not allowed? For example, in action we define what are allowed, those commands are allowed. But what if there are only few of those?
So you can always extend these plugins to make sure they work the way you want. You can write your own plugin. I guess this plugin by default just provides you a simple actions array where you can define just the command that you want the users to be able to run. But it is extensible. I haven't hacked it yet, but it should be easier to do it. Anything else? Thank you.
Thank you so much, Mr. Trump and eye-opener. So you will have yellow color cards with you, and please give them feedback. Also, you have a white color card. If you have any feedback, suggestions, things to improve for the event coordination, everything, anything, and any issues you face during this, do feel free to write about it, and we'll try our best to improve. Thank you so much everyone for coming to the event. We have some 5-10 minutes if you want to chat among yourselves, if you want to chat around with the thought workers, the speakers, do feel free to. And again, do follow the GeekNight NCR page in case you want to stay updated with us. The videos are already online. We'll be also putting up whatever code, whatever presentations they have put up today. And thank you so much for coming.
Thank you.
Even feedback, sir. Sorry? Even feedback. And it would be really nice if you can write more than thanks.
If I missed the white one.
You can have